Hello students, welcome to my channel. Today I am here to teach you class 9 cbse's first chapter, that is matter in our surrounding. So first part we have already learned about some physical nature of the particle. So in this class we'll be studying about characteristics of particles of the matter. So we have to study about the characteristics of those particles which are present in the matter. So let us begin with the first character. Particles of matter have space between them. So particles which are present in the matter. So as we know that matter is made up of particles. So these particles have a space between them. So we need to prove this. How do you tell that particles have space in them? In activities 1.1 and 1.2, we saw that particles of sugar, salt, dettol or potassium permanganate got evenly distributed in water. So that is in my previous video. We saw that how sugar, salt, dettol or potassium permanganate got dissolved in water and got distributed in water evenly. Similarly, when we make tea, coffee or a lemonade, that is nimbu pani, particles of one type of matter get into the spaces between particles of other matter. So we will take an example of milk. Okay, milk is one type of matter and sugar is the other type of matter. So when you are mixing this milk and sugar, so the particles of sugar get distributed or get into the spaces of the particles of milk. So similarly it is with tea, coffee, nimbu pani and other type of matter. So particles of one matter get distributed in the other matter. So this shows that there is enough space between the particle. That is why the particle of one matter can be distributed in the other type of matter. So this was the first character, that is particles of a matter have space between them. So they have space between each other. So the next characteristic, that is particles of matter are continuously moving. So matter has particles, so it also has space between them, and we need to know that they are continuously moving. How do you tell that they are continuously moving? So here we'll go through some activities to tell that the particles of the matter are continuously in motion or they are moving. Put an unlit incense stick in a corner of your class. How close do you have to go near it so as to get its smell? Now light the incense stick. What happened? Do you get the smell sitting at a distance? Record your observation. So you need to take an incense stick, that is a agarbatti, and light it in the corner of the classroom and sit in the other corner of the classroom and observe that do you get the smell of that agarbatti sitting in a distance. And we'll go to the next activity, that is activity 1.4. Take 2 glasses or beakers filled with water. So you have to take 2 beakers that should be filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. So by taking 2 beakers filled with water, so in the first beaker you need to drop some blue ink or a red ink from the sides of the beaker, and in the other beaker you need to drop honey in the same way. Leave them undisturbed in your house or in the corner of the classroom and record your observation. You have to do this experiment and leave it in a corner and you have to record those observations. What do you observe immediately after adding the ink drop? So we'll observe when you add a drop of ink, so ink will start getting distributed immediately. What does you observe immediately after adding a drop of honey? So when you add a drop of honey, what happens? The honey gets settled down in the beaker, and after hours, that is after 3 hours, after 6 hours, the particles of the honey will be mixing up with the particles of the water. How many hours or days does it take for the color of ink to spread evenly throughout the water? So when you add a drop of ink to the water, it will take less time when compared to the honey. Honey will take more time, that it might take a day for a honey, particles of a honey to get distributed throughout the beaker, but whereas the particles of the ink get distributed immediately, very fast when compared to the honey. So you can see in the image here, in a conical flask there is a drop of ink adding. So how evenly the particles of the ink are getting distributed, and but whereas the honey, that will be getting distributed very slowly when compared to the ink. So activity 1.5. So drop a crystal of copper sulfate or potassium permanganate in a glass of hot water and another containing cold water. So here you have to take two beakers again. One should contain hot water and other should contain cold water. You can see in the image there. And you should add a drop of copper sulfate or potassium permanganate in it. You should do not stir the solution. Allow the crystal to settle at the bottom. So this potassium permanganate and copper sulfate are in the form of crystals. So when you drop this in cold and hot water, so you shouldn't stir that solution, and you should allow the potassium permanganate or copper sulfate crystal to settle down. What do you observe just above the solid crystal in the glass? What happens as time passes? So what does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how? From the above three experiments, and we can conclude the following. So we have done so many experiments. That is, the first experiment was about the incense stick in the classroom, that is agarbatti, lighting of the agarbatti in the classroom. And the second was two beakers taking up a ink, color of ink, and other the honey. And the next experiment is about hot and cold water, potassium permanganate crystals in hot and cold water, so which get distributed very fast. So particles of matter are continuously moving, that is, they possess what we call the kinetic energy. So these particles of matter, they are continuously moving in the water, that is, the particles of water are moving, and also the particles of the color of ink, honey, and potassium permanganate are moving as they possess some energy, that is kinetic energy. As the temperature rises, particles move faster, as we saw in the experiment 1.5, that putting potassium permanganate in hot and cold water. So what happens, the one which is in hot water get distributed very fast as the kinetic energy in those particles increases when the temperature rises. In the above three activities, we observed that particles of matter intermix on their own with each other. So we do not stir it or we do not force it to mix. They intermix with each other on its own. So they do so by getting it into the space between the particles. So as in the first character, we saw that particles have space between them. So they get the particles of one matter get into the particles of another matter as they have space between them. This intermixing of the two different types of matter on their own is called as a diffusion. What is diffusion? So when the particles of one matter get intermixed into the particles of other matter on its own, this type of process is called as a diffusion. We also observe that on heating, diffusion become faster. As we saw in the hot water, the crystals of potassium permanganate got distributed very fast when compared to the cold water. Why does this happen? Because of the kinetic energy. As the temperature increases, the kinetic energy in the particles also increases, and that forces the particles to get intermixed very fast. So we came across two characteristics, that is, particles have space between them. Particles of matter also are continuously moving. Particles of matter attract each other. This is the third characteristic we need to know about the particles. Particles of matter attract each other. So we are doing one more activity here, that is activity 1.6, 1.7 and 1.8 will be doing to understand the characteristic, that is the particles of matter attract each other. Take an iron nail, a piece of chalk and a rubber band. Try breaking them by hammering, cutting or stretching. So you try to break the iron nail by hammering it, and try to cut the piece of a chalk and try to stretch a rubber band. So in which of the above three substances do you think the particles are held together with greater force? So when you are doing such thing, you will see that you need to give some amount of force to break them, that is either by hammering, cutting or stretching. So when you do all these three things, you will get to know which matter exactly will require more energy or greater force for breaking them. So activity, iron nail requires more force as the particles of these matter are very closely or very attractive with each other. A particle of chalk can be broken easily, and a rubber band can be stretched for a long time and can be cut. So activity 1.6, play this game in the field. Make 4 groups and from human chains as suggested. So you can see in this image you have to make 4 groups like this, and in the first group should hold each other from the back and lock the arms like Idu Mishim dancers. So in this way you have to lock, that is interlock your hands from your back, and from the second group should hold hands to form a chain. The second group should only hold their hands. The third group should form a chain by touching each other. They shouldn't hold the hands, they should only touch each other on their fingertips. And now the fourth group of students should run around and try to break 3 human chains one by one into as many as small group as possible. So by making 4 groups, one we have to make like from the back you have to hold it very tightly, and the second group they have to hold the hands, and third groups only touch the fingertips, and fourth group should try to break those groups, 3 groups. Which group was the easiest to break and why? So it is the third group we can break by easily, because they are just holding their fingertips, so we can easily break them. But the hardest was the first group, which were locking their arms. If we consider each student as a particle of matter, then in which group the particles held to each other with the maximum force? That was in the first group. Activity 1.8. Take some water in a container. Try cutting the surface of water with your hands. Were you able to cut the surface of water? What could be the reason behind the surface of water remaining together? The above 3 activities 1.6, 1.7 and 1.8 suggest that particles of matter have great force acting between them. This force keeps the particle together. The strength of this force of attraction varies from one kind of matter to another. So this is the third activity. You have to take a container, either it might be a beaker or a glass or something, and you have to try breaking the water. Water also is a matter and which has particles in them, and even they attract each other. So we have to try breaking them. Is that possible? No, it is not possible. Here we came across these 3 activities and we got to know that particles attract each other with some kind of force. This force is greater in some matter and it is less in the other matter. So various force of attractions are there between the matters, and it differs from one matter to another. So in this class we studied about the characteristics of particles of a matter. So first characteristics we studied that particles have space in between them, and the second characteristics we studied that particles of the matter are continuously moving. As we saw, the ink get colored and the water particles get mixed up with the honey particles of the honey, and we also saw how cold and hot, that is the temperature, vary when the kinetic energy increases in the particle, the diffusion takes place. So we also studied about a new process, that is diffusion. So what is diffusion? Diffusion is nothing but the intermixing of the particles on their own from one matter to another matter is called as diffusion. So in the third characteristic we studied, that is particles of the matter attract each other. So there is a force between these particles, so which make the particles of matter attract each other. So different matter have different force of attraction between them. So some might have less force of attraction and some might have maximum force of attraction between them. So these were the three characteristics. One was particles have space between them, and particles of the matter are continuously moving. Particles of the matter attract each other. So in my next video I'll be solving some questions which are given in the exercise of your NCERT book. So we will solve those and we will proceed to the next characteristics. So thank you for staying connected.